So last lesson, we left off here, and we determined that sometimes when it appears that there are only two solutions, that's interesting, and you zoom away and it still appears there are only two solutions. When you zoom in to a certain spot, you can see by zooming in extremely close whether it actually touches the x-axis at all, touches it once or twice. So using that same mentality, I want you guys to see if you can find all the roots graphically. Okay, I don't want you to do this algebraically. That would be a nightmare. An absolute and utter nightmare, which we are not prepared to journey down that path. So, put that in your calculator, see if there's any roots. Maybe there's one, maybe there's two, maybe there's three. Question, can there be zero?
Yeah.
Yeah, there can be zero roots, but for functions, can there be zero roots for this one?
No.
I heard sure's, I heard no's. Who can explain why?
It's x, so it has to go like.
Okay, parabolas, anything that has an even degree, which means that exponent is even, means like a parabola. It either goes up forever, both ways, or down for, yeah, I'll be okay. Down forever both ways. That means if I had an axis here, there's the x-axis, yeah, sure, that can not touch. I mean, that cannot touch there, it can touch once, or it can touch, yeah, twice. But when you have something that is odd degree, that goes up forever and down forever. If it goes up and down forever, it's got to cross the x-axis at least once. It has to. So you should have at least one solution there. Maybe you'll have two, maybe three. If I had two, it would look like this. Maybe you come up, touch it once, and come up. There's two. That's a good example of two. What about three? Well, maybe it comes up, comes down, and up like that. So it is either one, two, or three in this situation. Can it have more than three? No.
Because the exponent is only 3.
Yes, that's the maximum number of roots it has. Just a quick little review, Joe. All right, have a couple minutes. Okay, so how many solutions are there?
1.
3. Very good, very good, very good. So, this is what we're going to do here. That's nice. Can anyone tell me if you round to the nearest, let's call it thousands, that's how many decimal places? 3. Can anyone tell me what the solutions would be?
-3.
Negative
No, wait.
3.00. Okay, so it's 3. What else?
1.1.
1.1. I got 0, 0. And what's the last one? 1.150. Okay, if we round it to the thousands. Now, if the answer's a whole number, I would -3 was okay. Yeah, if one of the answers is a whole number, that's fine. I just picked the thousands, just randomly picked that one. Obviously, rounding to the hundreds would have been fine here or whatever because of zeros. But let's take a look at this, okay? Let's see if you're right. So I'm going to turn this on. And the first thing I'm going to do is I'm going to hit second plus 712. That resets everything in the calculator because other pre-calc classes, other two classes, calculus classes use these calculators. I just cleared that out. Here is the part where people will make a mistake, typing things in. It is a little bit more complicated to type in because there's so many decimals and exponents, so don't mess it up because you will definitely not get the answer if you mess it up. Right? Minus 54.85x plus 37.95. All right, I typed that in good. And I have a 10 by 10 window here. All right, so let me view attached LCD. Now, I can definitely tell here that it touches once. So let me see how. Yep, that's not gonna get any bigger. Okay. Ah.
It's all going out.
I know I'm recording. All right. It touches once here. The question is, what happens here? Does it go above? Does it touch once? Or does it go through and touch twice? You have to zoom in and check that out. All right? First, let's take care of our one dot right here. Okay? That looks like it crosses at -3, which is what you told me the answer was. I can do the bow tie thing or because it's a whole number, where else can I see if it's a 0? On the table. At -3, it in fact is a 0 for the y, so that is a solution. So I go here, so this one works. Bang. Let's check to see, and it sounds to me like you guys think this point touches twice. Well, let's zoom in there, okay? I hit zoom, I'm going to zoom in, and I move my little spider dude. See that little movie thingy? I'm going to put that right on the x-axis and enter. There it is. Okay, it looks like it still touches once. So I still have my spider thingy here. I'm going to hit enter again. And, okay, it looks like it dropped below. This part here tells me that it looks like it drops below. But I still can't do my bow tie zeros function unless I zoom in one more time. So I'm going to take my spider thing and still there and hit enter one more time. That is so freaking obvious it crosses twice. Now I just do second, trace to get my calc function. I'm going to calc the zeros. And I got to do my bow tie. I'm going to start with this left one here. Remember, the calculator's asking me, you know, left. Okay, so I've got to be left with my 0. That's left, I hit enter. That's right, I hit enter. I made my bow tie here. Yeah. And then I hit enter. It's asking me to guess. It's saying, you want to guess? Yes. This is why I do this. I don't do this for kicks and giggles. And the answer is 1.1. So, good. We just got to check the last one. And by now, I'm not going to go through instructions on this. You guys should be getting pretty good with this. I'm just going to go ahead and do it. Calc, go to my 0. I got to go left of this dot right here. So down and to the left, up and to the right. I made my bow tie. Hit enter one more time. 1.15. Good job. It's that simple. There'll be one like that on the quiz. Tomorrow. I'm just kidding. We're just doing a quiz. We don't have a quiz tomorrow. Because you guys all freak out. All right. Okay. Prove that 6 is a factor of n cubed minus n for every positive integer. Is looking at your table proof? First of all, let's think about this. If I graph in y1, and I use x's instead of n's, because our calculator uses x's for variables. If I put an x cubed minus x in the calculator, okay, instead of n cubed minus n, and I looked at my table, this is what I would get. So look at, for every positive integer that we put in here, 1, 2, these are positives, I guess, 3, 4, 5, 6. They're saying the output is a factor of 6. Are all these outputs factors of 6? Well, 0, I guess. Maybe. 0 times 6 is 0. 6 is a factor of 6. 24 is a factor of 6. 60 is. 120 is. 210. Trust me, it is. Because 0 times 0 is just a factor of everything. It's a weird way to think about it. So, can I just say, yeah, I look at my table and all those numbers are factors of 6?
No.
You can't, because that table goes forever. So you don't know if it's going to, at 1 million, what's going to happen, right? Is it going to happen? You don't know. What about, well, yeah, 1 million is. What about 999,732? Right? You're going to have to check every one. So we're going to have to do this algebraically. So looking at your table proof, no. How come? Because it's infinite. It goes on forever. How can you infinitely check them all on the table? That's my Spider-Man eyes. Spider-Man. 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 Ba-ba-doo. 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 Ba-da. All right.
I thought that movie had that.
So how do I prove this? I'm going to prove it algebraically. I'm going to prove it algebraically. Allie. I'm going to prove it algebraically. There's never a question when you prove something algebraically if it works or not. For instance, they're asking me n cubed minus n are all possible values of n in this case. Will that give you factors of 6? Well, let's break this down. Let's factor this because they're asking for factors, right? So let's factor this. What is it? What's the first thing I can do here? Go ahead, say it. I can take out an n. I have n times n squared minus 1. All right? Can I do anything else? Thank you. This is a quadratic that can be factored. This is n times n plus 1 times n minus 1. I'm telling you, the n squared minus a perfect square. I mean, this is big even in calculus. You just got to know that. What is x squared minus 25? It's x plus 5, x minus 5. What is x squared minus 9? X plus 3, x minus 3. What is x squared plus 64? No, if it's a plus here, you cannot do that. It's a minus.
Oh.
Because the middle term's got to cancel. Plus times a minus would cancel. Okay? But if this was a minus, that'd be x plus 8, x minus 8. You just got to know that. That's a big one to know. So now let's take a look at what we got. We factored this completely. Didn't we? Did we?
Yeah.
Yeah, we factored it completely. So let's take a look at this in terms of values. If I had a number n, someone pick a value for n. Let's do this. Why would you guys go crazy like 100? We can do 100 too. No. But let's make it easy to start.
4.
Wait, I heard 5. I heard 5. Let's say n equals 5. What is n plus 1? 6. What is n minus 1? So no matter what number I pick for n, aren't these 3 consecutive numbers? Okay, let's say I picked, someone said 2 for n. That means n plus 1 will be 3, and minus 1 will be 1, wouldn't it? I'm always going to have 3 consecutive numbers that I'm multiplying together here, aren't I? Because I'm multiplying n times n plus 1 times n minus 1. In multiplication order doesn't matter, does it? I can write that n minus 1 times n plus 1. I mean, I can do that. I'm multiplying 3 consecutive numbers. Our first thing said 4 times 5 times 6, right? So if I multiply those together, wouldn't they be a factor of 6? They have to be. You're multiplying it times 6. Correct? All right. Now let's pick 1, 2, and 3. What if I'm multiplying 1 times 2 times 3? What's 2 times 3? 6. That's 1 times 6. Isn't that a factor of 6? The 6 is in there. Pick another 3 consecutive numbers. So is that 100?
8.
8. Okay. What if I do 7 times 8 times 9?
You want to go that one.
What is 8 times 9? 72. Isn't that 12 times 6? Still times 7? You will always get a 6. Do you want to know why? Because every 3 numbers will always have a 2 and a 3 in them somewhere.
Yeah.
Isn't 8 4 times 2? Isn't 9 3 times 3? You still have your 7 here, right? What's 2 times 3? 6. It's going to be a factor of 6. Every 3 consecutive numbers will have a factor of a 2 and a factor of 3. We just did. It's how you explain it. Every 3 numbers, every 3 consecutive numbers will have a factor of a 2 and a factor of a 3 in it, which means it has to be a factor of 6. It has to be. It has to be. Does everybody understand that?
Every 2 numbers, with 3
consecutive numbers. With 3 consecutive numbers, well, they said positive, didn't they? Did they say positive numbers? Positive integers. So let's use that, okay? With every 3 consecutive positive numbers or integers, you get a 2 times a 3, which reduces, I'm going to say therefore, factor of 6. Those 3 dots mean therefore. Those 3 dots mean therefore. Okay, so pick 3 more numbers. Well, someone said 100, right? 99 and 101. Isn't this 2 times 50? And isn't this 3 times 33? Isn't 2 times 3 6? So I've got 33 times 6 times 50 times 101. Yeah, it's a factor of 6 because you're multiplying it by 6. Every 3 numbers, you will always get a factor of 6. Always. Always. Doesn't matter how far. You can go on the table infinitely. Yeah, thank you. Thank you. Because 2 times 3 is 6. Okay? Give me a number I can multiply by 6. The smaller number will start. 6 times 5, that's 30. Is 6 a factor of 30? Yeah, because 6 times 5 is 30. So as long as I'm multiplying something by 6, whatever this product is, 6 will always be a factor of it. It is 6 times some value. This value happens to be 33 times 50 times 101. 33 times 50 times 101. Always. Example 7. Prove that n, if n is a positive integer, then n squared plus 2n is either odd or a multiple of 4. Oh my goodness gracious. Compare your proof with those of your classmates. So what are we going to do? What are the steps we're going to do first? We're going to factor it. Then we're going to take a look at what we have and logically explain why it will either be odd or a multiple of 4. Let's begin. Let's go. No one should be talking if you have nothing on your paper. That's a rule. Okay? So, and no one should be talking about nothing written on your paper for the problem. Unless you're talking about the problem, which clearly some people are. All right? So if I factor this, what do I have? I can factor out an n, and I have n plus 2. Can I factor that anymore?
No.
So just like the last problem, when we had the last problem, we came up with Spider-Man. We came up with n times n plus 1 times n minus 1, and what did we figure out? That was what? 3 consecutive numbers, right? Right, so now look what we got. N times n plus 2. That plus looks like a multiplication sign. There you go. Plus. So what do I have? Okay, pick a number for n.
2.
2. What's the next number?
It's going to be
What's n plus 2? If this is n, what's n plus 2? That's right, it's 4. Pick another number for n.
8.
5. What's n plus 2?
7.
So what do you notice about this set versus this set? They are consecutive, even, or consecutive odd numbers, depending on what you select for n. So if I add 2 consecutive odd or consecutive even numbers, okay, depending on what you pick for n. Every time I add 2, if I have an even number and I add 2, it's going to stay even. 2, 4, 6, 8, 10. If I pick an odd number, 1, it's going to stay odd if I add 2 to it. 1, 3, 5, 7, 9, and so forth. So we have 2 situations. If n is odd versus if n is even. No, don't you worry. If n is odd, what is the product of 2 consecutive odd numbers? What is 5 times 7? 35. Is that odd?
Yes.
It is. Pick another 2 consecutive odd numbers.
9 and 11. 9 and
Consecutive odd. 9 and 11. What's 9 times 11? Is that odd? Yes. So,
I got one.
the product, what is it?
It's 5 times. Yo, it's just
3, because that would be consecutive. And 5, we did 5 and 7.
okay.
That'd be 15, which is odd as well. The product of 2 consecutive odds is always odd. Okay? That's the first part of our answer. Because they want me to prove that it's either odd, which we just did, or a multiple of 4. So let's take a look at what happens when n is even. What happens when n is even? What is 4 times 2? That's 8. Okay, that's even, and that is a multiple of 4. Okay, pick another 2 consecutive even numbers.
4 and 3.
Okay, even numbers.
Okay.
10 and 12. That's 120. Guess what? 4 goes in there 30 times.
I can pick one. It's gonna be 2. 2 and 8.
Consecutive even numbers. They
I
gotta
don't
be
get it.
consecutive.
Wait, what is consecutive?
That means the next even number. Like 2, the next even number is 4.
Oh, okay.
8, the next even number is 10. 8 and 10 is 80. That's 4 times 4.
Okay, because I'm saying
Okay.
numbers.
So the product of 2 consecutive even numbers is always divisible by 4. Because you're always going to get 2 times 2 in there. You don't have to write that. You're going to get 2 times 2. Okay, let's take a look at that 8 times 10. Well, this is 4 times 2, right? This is 2 times 5, right? So isn't that 4 times 4 times 5? I mean, it's divisible by 4. It's a factor of 4. You have 2 4s in there. Yeah, you always will. What if this was 18? That would be 9 times 2, right? So that'd be 9 times 4 times 5. You have a 4 in there. You always will. You always will.